Now, rather than to look at the spectrum of the light source, what we're going to do is look at the operation of the grating itself. It's mounted in one of the bar-type lens holders. It could also be mounted in a little slide holder. Typically, when this lab is done, the screen is placed at quite a distance, so there's room to make measurement. I have it close here for the purposes of the videotaping. You can see this central order and 2 orders to either side. There are no more orders than that, and I can take a piece of paper and hold it up close, and you can see that in fact there's only the 0th order in the center and the 1st and 2nd order fringe to either side, and that's it for this particular diffraction grating. So we can use the known wavelength of the helium neon laser and calculate the spacing. We can use the known spacing and calculate the wavelength of the helium neon laser. The measurements that need to be made are the measurement from the diffraction grating to the screen, called X in the lab, and the measurement from the central fringe to the 1st order fringe, 2nd order fringe on either side, or for increased measurement accuracy, take more measurements and measure on both sides. One interesting thing to note is that if I slide this around, you see all kinds of strange fringes appearing. And if you look closely at the plastic grating, you'll see that over time they develop scratches, and that's what this is. These are actually diffraction through the scratches that are going across, well, in every direction. That's kind of neat. I ask students to identify the source of those additional fringes. One additional thing that I'd like to show is what happens when a different color passes through the diffraction grating. The diffraction grating equation has a lambda in it, so the amount that the fringes spread is, of course, dependent on wavelength, but that's sometimes difficult to show because the most convenient source for this lab is a helium neon laser. I have here a yellow helium neon laser, and when I turn that on, you can see that the 0 orders are pretty well aligned, but the 1st order for the yellow is not diffracted at as large an angle as the 1st order for the red, and even more so for the 2nd order. The 2nd order yellow is here, and the 2nd order red is here. One interesting thing about this yellow helium neon laser, I turn the red one off, is you can see when you get out into the 2nd order in either direction that there's a little bit of orange. And in fact, this laser has a problem. It's perhaps the mirrors are misaligned slightly. Whatever the cause, there's a little bit of this orange 604 nanometer as well as the 594, which was the color that we purchased. So the diffraction grating shows very clearly that there are 2 wavelengths contained in this particular laser, whereas the red Heaney is a single color, 532.8 nanometers. And that concludes the diffraction grating.